A very good morning to all of you, dear students. So, in this practical class, we'll be learning about the preparation of gold nanoparticles using the tea leaves. Before we actually start with the preparation, let us understand what are the gold nanoparticles. These gold nanoparticles, these are defined as the stable collide solutions. So gold atoms, they are clustered together to form the colloidal solutions, whereas these clusters, they are in the range of 1 to 100 nanometers. And you'll be surprised to know that these clusters or these colloidal solutions, they are never yellow in color, what we know are gold to look like, but rather these nano solutions, these are red, orange, or even blue in color. So on what factor does the color of the solution depends? The color of the solution, it depends on the shape and size of the nanoparticles. Like these gold nanoparticles, they are forming the cluster solution of different size. We are talking in the range of 1 to 100 nanometers. So depending on the size of the clusters, you will be getting different solutions of these gold nanoparticles. Similarly, when we talk about the shape of the nanoparticles, these nanoparticles could be spherical in shape, they can be rod like. So depend on the size and shape of the nanoparticles, we will, and the dist and of course the distance between them, we will be getting the different solutions of the nanoparticle. So let us understand what is the major difference between the bulk gold and the nano gold. Bulk gold, we all know, is a shiny metal. It is always bright or golden yellow in color, is inert to many of the chemical reaction, and it is a very good conductor of electricity. Whereas these gold nanoparticles, the color of the gold nanoparticle is never yellow. It depends on the shape and size and the distance between them. So all these factors are responsible for the different colors of the gold nanoparticle solutions. So they are found in a wide range of colors. These nanoparticles, they are very good catalysts, and these do not show the properties of the metals, but they are actually the semiconductors. To synthesize the gold nanoparticles, two approaches are generally used. One is the top down approach, wherein we start with a bulk and then it is fragmented to the level of gold nanoparticles. This approach is called the top down, means we are starting with the bulk and then we are reducing down the size to the nanoparticles. The other approach is the bottom up approach, where we start with the atoms, we form the clusters of these gold atoms, and then we reach to the nanoparticle size of these clusters. So this approach is called the bottom up approach, and this is in fact the approach which is used in the preparation of the gold nanoparticles in the laboratory. Conventionally, these gold nanoparticles, they can be synthesized by adopting two methods. One is Turkovic method, where we start with the auric salt. This auric salt is reduced with the help of citrate ions at 100 degrees Celsius to give the auric atoms with the zero oxidation state, and then these auric ions, then they start forming the clusters. And what is the size of the cluster? What controls the size of the cluster? The size of the cluster is controlled again by the citrate ion, because in this case the citrate ion is performing a dual function of acting as a reducing agent and also acting as a stabilizing agent or the capping agent. So the it is a agent which caps the gold nanoparticle and which stops the gold nanoparticle, which prevents the gold nanoparticles to form a big cluster size, and it actually let the gold nanoparticle to form the clusters in the range of nanoparticles. So citrate ion is performing a dual function, one as the reducing agent and the other as the capping agent. In the Schiff burst method, in the previous method we have used the citrate ion, and in the Schiff burst method we use the sodium borohydride. This sodium borohydride is used as the reducing agent, so which is used to reduce the auric salt, the Au3 plus salt, to the auric 0 oxidation state. So it is able to reduce it to auric 0, but then we need something which can control the cluster size, and to control the cluster size the mercaptans are used in this method, which is then acting as the capping agent for the gold nanoparticle in the Schiff burst method. Now these conventional methods have their own limitations. We are using the toxic mercaptans, we are using the organic solvents, which are, again, nowadays there is lot of discussion on the toxicity or the long term effects of the organic solvents. So in these conventional methods we are using the mercaptans and the organic solvents. The reaction time is also very long here. The reaction conditions are also not that simple. Like in the previous case we have seen that we are using the high temperature conditions, and besides this the biggest problem is the particles which we are getting, the nanoparticles which we obtain, they are non-uniform. We are not getting a uniform size of the nanoparticles. So let us now learn the green methodology for the synthesis of gold nanoparticles. So this slides gives you an overview how these green nanoparticles can be synthesized by using a green technology. In this methodology, we are using the tea leaves as the source of the reducing agent. Now, what is why green tea leaves, or the why the tea leaves they are acting as the reducing agent? Because of the presence of polyphenols in the tea leaves. So tea leaves have polyphenols. So these polyphenols are soluble in water. When we put the tea leaves into distilled water or deionized water and let it stir for some time, say 15 minutes, these polyphenols they are extracted into the water, and then these tea leaves are filtered off. So what we have is what the extract has, the polyphenolic compounds in it. To this extract of the polyphenolic compound, when we add the auric salt, few drops of auric salt are added, and then it is stirred again at room temperature for some time, say 15 minutes. So after 15 minutes of time, we will see that the pale yellow or mustard yellow color of the polyphenolic solution in the distilled water, it changes to red in color. Okay. So again, we may get different color solutions. Some students may get uh, less light brown color solution, some students may get red color solution, so it, or some may even get some blue green kind of a solution. So it depends on what type of particle size is present. Some students by mistake, if they let the tea leaf stir for a longer duration, many polyphenolic compounds and the other compounds are extracted. So that is why it is important to control the time and the amount of the tea leaves and the auric salts here. So this will give us a red color solution of the nanoparticles. So by adopting the green methodology, we are preparing red color nanoparticles. These nanoparticles, the preparation methodology is cost effective, is environment friendly. Why it is cost effective? Because we are not making use of any expensive reagent. We are not using the sodium borohydride, we are not using the mercaptans, we are not using the citrate ions. So but we are only using the tea leaves, which are very easily available and of course very cheap also. And this methodology is environment friendly. Again, We are not making use of any harsh chemicals, any strong organic solvent. So we are doing the experiment in a experimentally benign condition, environmentally benign conditions. So we are making use of solvent, that is water. This methodology is energy efficient because no heating is required. It is done at the room temperature. We are not making use of any toxic reducing or capping agent, and renewable feedstock is used. And what is the renewable feedstock? The renewable feedstock is tea leaves in this green methodology. So now when we say we have synthesized the gold nanoparticles, how do we characterize it? One way, when we are performing the experiment, if we see the color change from pale yellow to red, that indicates that the gold nanoparticles are synthesized. But as I said in the second slide, that these gold nanoparticles, the solution is a colloidal solution. So what I expect is my gold nanoparticle solution should show me the properties of a colloidal solution. So this is what we are doing. So if I take a test tube and let the laser beam pass through it, the laser pass through it, I will be only seeing two spots, one at the entry point and the other at the exit point. So the path of the laser beam is not visible. Similarly, for the aurichloride solution, the path is not visible, whereas for the gold nanoparticle solution, I can see the path of light. Why? Because the gold nanoparticles are present in between, which are able to to reflect the light, and it's to scatter the light, and our eyes are able to receive that scattered light, and that is why we are able to see the path of light in the colloidal solution of gold nanoparticles. Another way of characterizing it by recording the UV visible spectrum. When we record the UV visible spectrum of the gold nanoparticles, and if we observe the lambda max in the range of 530 to 560 nanometers, that also indicates the presence of the gold nanoparticles. So in the laboratory, we can do the characterization simple by simply adopting two methodologies, by letting the laser beam pass through it, and then the second method is by recording the UV visible spectrum. So now the question arises, why are we doing this preparation? What is the applications? Why are we learning this? What is the application part of these gold nanoparticles? So students, nowadays these gold nanoparticles, they have found extensive application in the field of medicinal chemistry. These gold nanoparticles, they have been used for the targeted drug delivery, wherein the drugs, they are they are targeted to the specific site, and they are just not delivered anywhere in the body. And similarly, they are used as the biosensors in bioimaging. They are used as the catalyst to carry out various conversions in the gene delivery, as the antimicrobial agents, in tumor imaging, bioassays, and lot many more. That is the reason why learning this methodology, where the gold nanoparticles can be synthesized, they have their own industrial importance. Okay, so I hope everybody has understood the preparation of the gold nanoparticles, their comparison, how the green methodology is better than your conventional methodology, and how these gold nanoparticles, they can be characterized by using the UV spectrophotometric method, and by making use of the colloidal properties of the gold nanoparticles. Thank you for your patience.